So the generic term blood cancer means whatever cancers that arise from the bone marrow. So that's not limited to just the leukemias. There are diseases like lymphomas, myelomas, and certain other malignancies which come from the bone. And these are all collectively termed cancers of the blood. But when we specifically say blood cancer in our parlance, we generally mean acute leukemias specifically. So every 35 seconds, the incidence is that there is one person getting diagnosed of a blood-related cancer in the world. And every 5 minutes in India, that is the statistics. And you can imagine the sheer burden of that disease with a population of ours. So there are acute blood cancers which kill very quickly, and these are called acute leukemias. And they are the worst of the condition. Before, within a few weeks, they manifest and they have to be treated very quickly. And then there are chronic leukemias which can be treated easily because they present slowly, they don't kill, they give you time to react and there are still other diseases like lymphoma which is still slower, myelomas which also develop similarly. They are all largely treatable. Some are curable, and certain leukemias which can be, which otherwise will not be curable, like acute leukemia, AML. Diseases like acute myeloid leukemia, relapsed acute lymphoid leukemia, or relapsed refractory lymphomas or myelomas can be cured by transplantation. At least a significant amount of them can be offered some more disease-free interval, and some of them can be cured as well. We work with adult stem cells. So just like there are embryonal stem cells, there are stem cells in your skin. That's why, despite all the tanning and all that, your skin comes back. People have their hair back. Unfortunately, people like me don't, but, so stem cells come back. So there are places where they are constantly being regenerated. There are lung stem cells, liver stem cells. So there are stem cells in bone marrow also. And the function of this stem cell is to produce all other components of the blood. So you have hemoglobin, which brings oxygen around the red part of your blood. And then there is WBC, which is a white blood cell which produces all the infection-related immunity. The generic term you keep hearing is all thanks to different types of white blood cells. Lymphocytes have a certain role to play, neutrophils play some other role, eosinophils, different parts of the WBC repertoire has different roles to play in specific immune function. They produce more RBCs when RBCs are low, when they produce more WBCs when more WBCs are low, they produce more platelets downstream. It's like a factory which responds to a supply demand. And the very beautiful thing about a stem cell is that a stem cell can make another stem cell. It can make a stem cell and another cell, or it can make two stem cells if it wants. So this is called plasticity, which other stem cells only have. The differentiated cells don't have this. Self-renewal, and plasticity means that you can differentiate into a certain type. Stem cells can be easily harvested and stored so that we can give patients chemotherapy, which otherwise they will not survive. So it is or conditioning responses. Before we start a transplant, we'd like to eliminate the entire disease burden in the marrow, and we try to save the stem cells. And we try to see a matched person's stem cells. It is not through a bone marrow procedure. You don't have to go through anesthesia. If you have given blood or platelets to a single donor apheresis, then you can also give stem cells because the process is the same. We just use a different cassette for getting platelets. We use a different cassette for getting stem cells. Stem cells come into a nice bag, and after that, you're good to go home. So it's a very simple process. There is no significant side effects. There is absolutely no long-term side effects, just as much as giving blood, and the stem cells replenish very quickly. So it is actually the best thing you can do for somebody, because your stem cells can cure somebody's leukemia. In the stem cell donor drive, what we first ascertain is what is your body's composition. And this is called the HLA match. So when we do an HLA match, we look at 12 points in that, or maybe 10, depending on how high resolution or low resolution we are going. And then these 12 points are essentially numerical things which will give you a report something like A3241, B12 something. So essentially there are A, B, C major histocompatibility loci, and then there are DP, DQ, DR which are minor histocompatibility loci, and both these need to be matched. So we call a full match for a person who has all these matching with the patient. And we can find this out by swabbing your cheek or taking a blood test. The easiest thing is just swab the cells in your inner cheek, and we can study them, and we can understand the homology of your genetics. You must understand how special you are to match with somebody else on the planet, probably in the opposite place, a different culture, a different. But you could save his life by just donating 300 to 400 ml of your stem cells through blood transfusion, like just donating blood, and that's all it takes. So it's important for ethnicity to be recognized. So for these 12 points or 10 points or loci that we call, essentially think of them as numbers. The human leukocyte antigen or the HLA antigen is who you are genetically. It is you. Each cell of your body is this genetic code, and your immunity functions on this, because the function of immunity is to understand in your body what is self and what is not self, and what is foreign should be killed. So if every cell is HLA matched, it will understand this is me. There are some signals it gets. And your chance of finding a donor is best in the needle in the haystack that you're already looking for, is to have somebody who is Indian. Of course, by chance we always get people, we always do find some now and then, somebody Polish or somebody else. But the chance of a blood cancer patient from Bangalore getting a donor is highly likely in South India. And that's why we need more people to come out and take part in this, because you can save a life. The success rate of the transplant, depending on how bad the leukemia is to start with, we have high risk, low risk, intermediate risk, is anything from 25 to 35%. Some of them also get cured, and they stay alive and have a near normal life. But in myelomas, it is not curable. Autologous transplant will just prolong life for another 5 to 6 years. A small minority of them actually may get prolonged cure, prolonged control of disease. We generally don't use the word cure for myeloma. In lymphomas, it's a very good response rate, and relapse refractory disease, which is not responding to chemotherapy, has multiple times come back. In that scenario, we use it. And good responses, depending on the type of lymphoma, as high as 70 to 80%. And I'm looking around frantically for a donor, because I know in 14 to 15 days, if I don't get a donor and transplant doesn't start, I am going to relapse and die within 14 days. Now, this is a very hard-hitting reality, and it only matters to those people and families of those people who are affected by the disease. Finding a match in those 15 to 1 month, that gap that we have, is impossible without a registry. And DKM is one of the largest registries in the world. It's actually a German-based registry. They are the largest number of samples in the world. And appallingly, Indians, being the most populous people on the planet, have an appalling presentation there. If all of us can do this, patients in India will find a match. It will be cheaper for them to get the stem cells, because if you find a stem cell in Poland, the logistics involved to collect it in Poland and bring it to Bangalore or Thrissur and give the stem cells through the green path that we create through DKMS and the registry channels, it's a lot of money. And the chance of finding them is a needle in a haystack. Indians have a better chance of finding a match. GCSF stands for granulocyte colony stimulating factor. What it does is, the stem cells inside this bone marrow is actually attached to the inside of the bone by small pieces of protein, and GCSF essentially goes and works like molecular scissors, and it cuts these stem cells and lets them into circulation. Otherwise, under normal conditions, stem cells don't come into circulation. very, very uncommon. So the GCSF provides the stem cells, the cleavage, so that they can be released from the marrow, and that's how we collect them in the peripheral blood by putting a needle like how we collect blood. Peripheral blood stem cell is what this is called, is common and easy. Umbilical cord transplant is one source, and this is different. It has its own side effect profile, which is different. So the machinery to handle transplant is now at the back because COVID is the real problem, and the beds are all being converted to COVID beds. So very few centers have really the bandwidth to handle transplants at this time because cancers don't wait, whether COVID or no COVID. See, spondylitis is not an ineligibility. There are various different types of spondylitis. When we say spondylitis of ankylosing nature, which has some autoimmune etiology, which means that it's not just a simple wear and tear spondylitis. It's something that your body is causing because some proteins are found foreign and it is attacking that parts. So ankylosing spondylitis, which is actually B27 mediated, we do not. So India is underrepresented. Actually, is underrepresented for the same reasons why we don't have blood during COVID times in blood banks. Because everybody wants blood, but nobody wants to give blood. So you leave alone stem cells. We do not want to venture out and try and be a part of some help, unless it really bothers us, because it has to affect our immediate circumstances. Until then, it's not your problem. We don't want to give. I wish we could give, because it's generally the thought behind that is what will happen to me? Is this a problem? Is it going to create issues? Will something happen to me? I'm already anemic. Many other things like that. But that is a small subset of our patients and people. Most people are eligible to donate stem cells, just like they can give blood. It's such an anticlimax when you donate stem cells, because at the end of the day, they think, that's it? That's it? What's the hype about? The hype is the magic that happens afterwards. Like how they collect blood tests, maybe a little larger needle, that's all. So where is this being used? How is it being kept? Is it being manipulated? Is my identity being revealed to others? So these are very pertinent questions in this day and age, and you want your daughter or son's data to be protected. So there are some data standards which are maintained. The WMDA, the World Marrow Donors Association, has data privacy standards, and they also comply with the IT Act of 2000 and the General Data Protection Act. So these are very safe and compliant data practices as well, wherein anonymity is at the key of things. So nothing really to worry about.